Okay, today I'm going to teach you how to draw Lewis structures. Here's the basic steps for drawing Lewis structures of covalent compounds. Number 1, count the total number of valence electrons in your molecule. Number 2, assemble a framework of atoms with 2 electrons per bond. Step 3, fill in the outer atoms for a total of 8 electrons for an octet. Number 4, after filling the octet of the outer atoms, fill the octet of the inner atoms. Number 5, when you run out of electrons before satisfying the octet on an inner atom, create double bonds, or triple bonds if needed, using electrons from the outer atom. These first 5 steps are most important. In some cases, you will need to optimize with formal charge, and we calculate formal charge by counting the number for each atom by counting the number of valence electrons, subtracting off the number of bonds, and then subtracting the number of unpaired electrons. Number 7, identify possible equivalent resonance structures. I'm going to show you some examples. Our first example is carbon dioxide. So we're going to count the number of valence electrons. There's a carbon, which has 4 electrons. We have 2 oxygens, which each have 6. So 6 times 2 equals 12. We have a total of 16 valence electrons. Next, I'm going to assemble a framework of atoms. We always put the least electronegative or the least abundant atom in the middle. So I'm going to place the carbon in the middle and my oxygens on either side. I'll put bonds between the carbons and the oxygen. Each bond, remember, has 2 electrons, so I have used 4 electrons. I have 12 left. So to fill the octet of the outer atoms, the oxygens, I'm going to give them electrons. That used up 12 electrons, so now I have 0 left. But I have a problem because carbon only has 4 valence electrons, 2 for each bond. So now what I need to do is I need to borrow 2. I need to borrow 2 from one oxygen and put it into a double bond, and I'm going to borrow 2 from that oxygen, and now carbon now has an octet, as do the oxygens. For this example, I can calculate the formal charge of the 2 oxygens, and that is 6, the number of valence electrons, minus the number of bonds, minus the number of unbonded electrons, which have 4. And so the formal charge for oxygen is 0. The formal charge for the carbon, we calculate the same way. 4 valence electrons minus 4 bonds minus 0 unbonded electrons for 0. What we want is our formal charges to be 0, so this is good. Next example, ammonium. Ammonium, the number of valence electrons for nitrogen is 5. Hydrogen, we have 3 times 1, so that gives us 3. 5 plus 3 gives us 8. If I assemble a framework of atoms, I'll put nitrogen in the middle and hydrogen on the outside. I'll place bonds between the N and the H. Each bond is worth 2 electrons for a total of 3. I'm going to subtract off. I have used 6 electrons. I have 2 left. And hydrogen can only have 2 electrons. It's hydrogen and helium are the only elements that do not require 8. Or they are 2 of the ones that are exceptions. So I'm going to put my 2 electrons that are remaining on nitrogen, and now nitrogen has an octet. 2, 4, 6, 8. So this is a good Lewis structure. If I look at the formal charges for nitrogen, 5 valence electrons minus 3 bonds minus 2 unbonded electrons gives us 0. The formal charge for the hydrogens, they're all the same. It's 2 valence electrons. 1 valence electron minus 1 bond also gives it a formal charge of 0. So this is good.